So we are still talking about design aspects of a React app. So we're inside in this section here. Just a few minutes ago there, and I published this new card, which I'll talk about at the end of the lecture. And where we left off the last day was going through this set of slides, and I was talking about another design pattern, the provider pattern, if you can remember. Now, still on that kind of general kind of theme of design, but not so much from a patterns point of view. At the end of this set of slides, there's a section on custom hooks. So we know at this stage that hooks is a major part of the whole programming model, the React programming model. There are hooks that come with the React framework itself, and most up-to-date third-party libraries that are focused on React also provide hooks. We'll come across two of them actually in next week's lab. But we could actually design hooks as part of our own application. And so that's why I'm classifying them as custom hooks. They're just hooks that are specific to our application, our software organization, if the hooks are possibly applicable across multiple applications. So it's not the preserve of the React framework itself or third-party libraries. We can write our own hooks. And really, all I want to do is make you aware of the possibility, rather than expect you to be able to identify opportunities to refactor some of your code such that you can introduce your own hooks. We will introduce one custom hook in the Movies app, so you'll just get an insight into it. And it's still kind of under that general area of design, because we're always trying to improve the design of our code, whether it be React code or any code. And our objective always is, when we're trying to refactor, we're trying to improve the design, improve from a reusability, understandability, maintainability, all of those kind of characteristics. So it's still kind of consistent with that whole design theme. So a custom hook is a hook that we implement ourselves. And typically it arises when you see an opportunity to extract some code, some logic from a component and put that logic into a hook, into a function really, because a hook is nothing other than a function, but into a function that is going to behave like a hook. It's not specific, but usually the logic that you're extracting from an existing component is kind of state management logic. And the example that I'm just going to show you now is in that kind of vein. So let's supposing we have this fictitious library management system, and there's a component called the book page, and it's fairly obvious from the component name what that component does. It displays details about a particular book, let's say. And so at the moment, the way we've written it, we have a state variable that we've got a useState hook that looks like it's going to contain a reference to the book object itself, and it allows us to change the book object. In other words, change what page, or change the page to look at a different book, a bit like the movies details page, I suppose. We've got a use effect hook that's more than likely making an API call to some backend that is going to provide the book details, all fairly standard stuff. Now, this logic, let's supposing there were other pages in our app that required this kind of logic as well. So we don't like repeating code. So can we extract that code out of that component that we're looking at and put it into its own location? And the answer is yes. And that function that we're going to create and store that code in is an example of a custom hook. And so simply all you do, it's very straightforward in this case, you simply lift that code and put it into its own function. And I've purposefully and necessarily I've called the function, I've prefixed it with the use prefix because all hooks should begin with that prefix. And I explained kind of roughly why it's important to do that, because there are tools called linting tools that come with the JavaScript in general, but the linting tool that comes with the React framework, with the create React app tool, sorry, the linting tool that comes with the create React app tool, what it does is it scans through your code to make sure that you are using hooks appropriately. And I've told you before about, the fact that you can only invoke a hook at the top level within a component. You can't bury a hook invocation inside let's say, an if statement or inside in a for loop. That's not permitted. I never went into the details as to why it's not permitted. It would require a bit more understanding of JavaScript and all of that. So we'll just have to accept that that is a rule that you have to adhere to. Now, my hook, because it contains use state and use effect, it contains two native hooks to the React framework, my hook has to adhere to those rules as well. So by me prefixing this function name with use, that means that the linting tool that comes with create React app will also check to make sure that my custom hook is being used appropriately. But other than that, I suppose it's just an ordinary function, which I've implemented using the arrow style. Now, it would make sense, I suppose, that this function be passed in the ISBN number, because that seemed to be what drove this code here, right? The user entered an ISBN number. Well, in my case, it's kind of being passed down as a prop, and that ISBN number presumably is being used here to make the API call. So it's an important parameter. It would be an important parameter to my custom hook as well, because I'm still using the use effect hook here, and the ISBN number is being used somewhere. It's being used here. Look. So so the parameters to my hook are, you choose them sensibly, obviously, and this would be a sensible parameter for and necessary parameter for this custom hook of mine. In terms of what a hook returns, a hook can return anything you want it to. It just turns out, in my case, that the hook is returning essentially the same data that the use state hook returns. Where am I going to? Sorry, sorry, just give me 1 second now. Oh yeah, the use state hook here is returning a book object and the setter method, and it just turns out that my custom hook is returning the exact same information. I didn't have to put it inside an array. I could have put it into an object with appropriate keys for these two pieces of data. It doesn't really matter. I just stuck with the array as the return value. And so now if I refactored my code, that means that my original book page is simply, invoking my custom hook in the usual way that you would expect it to, right? And again, my hook is being invoked at the top level within my component code, so I'm adhering to the rules of hooks. And it's a straightforward. This example was very straightforward. Sometimes they're not as straightforward, but it is in this case. So yeah, I'm just saying, in one sense, your custom hook is an ordinary function, but it can only be invoked, or should only be invoked, from a component code. It would only make sense if it's invoked from a component, clearly. And I've kind of already made the point about prefixing the function name. And I've already made the point that your custom hooks can return anything. Typically, though, if you look across a broad range of hooks that come with third-party libraries, they usually return a collection of things, whether it be a collection in the form of an array or a collection in the form of an object. In fact, the hooks that we will look at next week, which are part of some third-party libraries, they are returning objects, but it can return any type of information. So that's it really. It's as straightforward as that in terms of this one anyway. And there's very little coding involved in my custom hook. Right, that's that set of slides finished. I'm going back to my website. I want to look at this set of slides here, and what it is I'm saying is it's just a use case for a lot of the stuff that we've looked at here and in the previous lecture set of lectures as well, to do with design and routing. So let's step our way through this set of slides. The use case in this case, the use case is pretty straightforward. Yikes. I still haven't worked out why it keeps doing that. All right. Okay. All right, got there. Not that I haven't, because there's something popping up on my screen now, which I need to get rid of. Right. My use case is I want to implement authentication for my React app. And I want to be able to declare certain routes as being protected or private. In other words, in order for a user to access a protected or private route, they first have to log in. They first have to authenticate, and the app will force them to authenticate. Other routes may be publicly accessible. So it's your typical kind of feature that you'd get in any kind of web-based app or native app for that matter. And I'm providing an archive with this set of slides, which is the archive there at the bottom. So usual story, download, unzip it, run npm install, and all of that. And when you run it, this is what you'll get. So on the top left is your kind of home page. And these two navigation links, home and public, are accessible to anybody. Whereas when a user tries to access either the inbox or the profile pages, then they're forced to log in. Also notice up here that the application knows that you're not logged in at the moment. Okay, so once the user tries to access one of these, then it will redirect them to the login page, and they fill in their credentials, which we don't care about, and they click the submit, and it validates them somehow. And assuming that they're valid, then the app will send the user to the page that they tried to access before they were forced to log in. We'd like that behavior, rather than sending them back to the home page and forcing them to click on the inbox page link again in order to get to where they wanted to. Right, so as I said, it's all fairly standard, but turns out that this kind of logic or functionality, you might expect the React Router library to provide a solution for us, but it doesn't, as it turns out. I'm also kind of highlighting here that the app does know whether you're logged in or not. So over here, you knew you weren't logged in, and once you did log in, then the header kind of changes and it provides a log out button. So it knows all of that. And if you click the log out or sign out, then you're automatically sent back to the home page. That's fairly standard as well, I guess. So as I was saying, there's no solution provided by the React Router. We have to implement our own. And really, all I did was I kind of Googled around the internet, and I came across a number of solutions, and you could too if you Googled on it. But there was one solution that I thought was quite nice in the way it was designed. And what was nice about it was that it adhered to some of the core principles of React, this declarative style of programming, which we would like to honor in our solution. Now, would it be nice if we could express are protected or private routes like this. So here's my routing configuration. And it's very obvious from the code, I hope, that while this path here is just an ordinary one, anybody can access it. Similarly for this one here, it looks like if the user tries to access if the user tries to access, sorry, this one here, this /inbox path, then it looks like it's declaring that is a protected route. I did say to you before, actually, I think I did, that what you assign to the element prop can be any JSX. And this is an example of it here. I'm actually assigning slightly more elaborate JSX to my element prop rather than this simple example here. But from a clarity point of view, I hope you'd agree that it is kind of clear that the /inbox it seems to be telling us that it is a protected route, and our understanding of protected route means you have to authenticate. We'll assume that we take that meaning from it. Okay, so, but there is no component called protected route. We have to implement that ourselves. And you could imagine what its kind of role would be. Check to see, is there a user already logged in? If there is, then go away and allow the inbox component to be mounted onto the DOM. If there isn't anybody logged in, then redirect the browser to the login page. In other words, change the browser's URL to /login. And when that happens, this path is going to kick in, or this route is going to kick in. So it's fairly predictable, but it's not straightforward, actually, as it turns out. And in particular, the part about when the user does log in successfully, then they are sent back to the page that they were trying to get at originally, that kind of remembering aspect to it. Now, the solution, there are a couple of parts to it, all of which we've seen in the previous two sets of slides. We're going to use a React context. Remember, context is this React construct that we can use if we want to share data across multiple components. And the thing that we want to share in this case is the fact whether a user is currently logged in or not. And I'm just going to use a token state variable to do that for me, because it usually, as you may know, when you log into some sort of application, the actual logic is carried out by some backend service. And if the username and password credentials are okay, then the backend service generates a random token, and that token is sent to the client, which is the browser in our case, and that token has a certain lifetime. And the token is evidence of the fact that the user is a valid user and that they have authenticated. And the token is usually some sort of long, meaningless string, hash value, essentially. So whether the token is present or not in my context will be the way I'm going to communicate to all the other components as to whether somebody has logged in or not. If the token is blank or null or undefined, then it means nobody is currently logged in. So we have to send them back to the login page. So the context, we're going to use a context construct to store this token value. We're going to have programmatic navigation, which I talked about in Monday's lecture. Programmatic navigation, you remember, is where we programmatically redirect the app. And we do that in a couple of places. We do that when the user tries to access a protected route and they're not logged in. We redirect them to the login page. And also after they have logged in, we redirect them to the page that they want to go to. We do that programmatically. So programmatic navigation is going to be useful to us. And as well, we want to be able to remember where the user was trying to get to before they were forced to log in. And it turns out we're going to use the location object to do that for us. So here's the code associated with the context, and I've called it the auth context for obvious reasons. And kind of take it from the top. Sorry, now bear with me for a second. Here I'm just declaring my empty context. Here's my context provider, if you can remember from the last slide. This is the component that's going to manage the context. Here is my state variable that's going to hold the token, and I'm initializing it to null. So I'm deciding if the token is null, that means nobody is logged in. I'll come back to this. I'm using the use location hook, and I'm using the use navigation hook as well, which I've mentioned the last day. Here's a function, and from its name, it seems this function will be invoked probably by the login page when the user has entered their credentials, their username and password, and click the submit button. So this function is going to run. Now, ordinarily, as I said there a moment ago, the validation of the credentials would usually be performed by a backend service. And just to simulate that, and obviously that's an asynchronous thing, and there would be a certain amount of delay in it. To simulate the delay, I'm just using this function called set timeout. The set timeout function is a function that comes with, that's built into your browsers. You pass it a callback and you pass it an integer. I'm sure you may be familiar with set timeout, but what set timeout does is it will delay the invocation of the callback until this number of milliseconds has elapsed. So essentially, I'm trying to simulate a delay between the user clicking the submit button on the login page and the validation of their criteria for no really important reason other than just to give that simple effect, right? Now, what does the callback do then? Well, I'm just hard coding a token. I'm setting the token value to this. Okay, so again, it's just simulation. So that's fine. And then I am, for now, you can take this line here as this is how I find out where the user was trying to go to before we forced them to the login page. And just take it as that for now. I'll explain this in a while where this is actually where this is coming from. So origin is going to contain the URL of either the inbox page or the profile page. So let's say it's going to be /inbox. And then I'm programmatically navigating to that location. I am assuming now, I'm not simulating the negative case where the credentials are invalid. I'm just taking the happy path. It would just be some sort of if statement if I wanted to take care of the happy path or the negative path. I'd send them back to the login page again. I'm just taking the positive case where their username and password are okay. So that's fine. That function implements or fakes the implementation of authentication. And for now, the important parts are, we're setting the token. So the token is going to have something other than null in it now. And if I just, the sign out function, which I've collapsed because we're not too interested in it, but clearly what the sign out function would do would be set the token back to null again. And it may do some other cleanup operation as well. We needn't worry about that for now. Here's what the context provider makes available to the rest of the app. It makes available the token because lots of other pages or components within my app may need to know, is there somebody logged in or not, and use that to determine what they should display or not, or do or not. And we're also making the authenticate function and the sign out function available to other components because we may want to allow the user to log in from lots of places or sign out from lots of places. Certainly the header, the site header is going to need to be able to invoke this one. So that's my auth context. The really important parts are it stores the token and it provides the function that will be invoked from the login page when the user clicks the submit button, which is this one here. And I have not explained this. That's okay for now. The protected route. So again, this is my route entry in my routing configuration. So what does this component do? This component we need to make that kind of decision. Is there somebody logged in or not? If there is, then send them to where they want to go to. If they're not, then force them to log in. And here's the implementation. It's trying to access the context because it needs to do that. And it's only interested in the token part. Okay, if I switch back, okay, I'm exposing the token to anybody that needs to access it. So this component here needs to access it. So that's fine. It has access to the token. I'm also grabbing the current location object. Now, when the user clicks on the inbox link, the browser's URL will change to /inbox because that's what's going to happen when they click the inbox link. If I go back, if I go back to here, when they click that link, it's going to be an ordinary hyperlink. Then the browser's URL will change to /inbox. And the browser will create a location object. And this is what the location object will look like. That's fine. However, my routing configuration says, well, this is the component that needs to mount, first of all, as a result of that. And here's the component here. And it's grabbing the location object. So it's getting access to this. What's it doing then? It's then checking, is the token, does it have a value or is it null? If it's null, because I've knotted it here, right? When the token is null is by default is false. So if I'm knotting it, that makes it true. Then I perform a programmatic navigation. I navigate to, or I change the browser's URL to /login. Now, what I'm doing here is I'm also adding some additional state, making some additional state available to essentially the login page, right? Because it's the login page that is going to be mounted as a result of the browser URL now changing to this. We had that in our routing configuration. And what am I passing on as some additional data to the login page? I'm passing on location.pathname, the path name of the current location object, which is going to be /inbox. So I'm passing that string. And that is where the user wanted to go to. That was their intent before they were forced to log in. You hadn't seen this from last week, from the previous lecture, but that's okay, right? So we're sending them, we're redirecting them to the login page. If the token has a value, which means this overall expression is false, then it skips over it, and it just returns children. Remember children? What's children going to be? In this case, children is going to be the inbox component. So the inbox page is going to display. And that makes sense. If the token has a value in it, then we don't want to force the user to log in. We just display the inbox page. Now, the more interesting part of though is when we do force them to log in. So we send them to the login page. Here's the login page. And again, it needs to access the context. And it's only interested in the authenticate function because it's going to be invoking it. Here would be my login page displayed on the screen. I've left out the username, password, text fields, and all that kind of stuff. So all I'm interested in is the button. I have an on-click handler. Here's the on-click handler. I'm just randomly generating a password, and I don't ever use it, but I'm just doing it anyway. And I call the authenticate function, which we talked about a few moments ago. And I'm passing it the username and password that were Maria entered on the screen. So this is just an ordinary function call. And so when we go back to that, we set the token, okay. So the user is okay. Now, this may make a little bit more sense. We're going location.state. And again, just ignore the question mark. I'll explain this in a second. This is an ordinary navigation. We're going location.state.intent. This expression is going to evaluate to, I know I'm jumping around now, to what you set it to here. Okay, so that's how we pass the intent of the user before we force them to log in. And you will probably need to go back and confirm that for yourselves. There's no point in me repeating it, unless you want to ask me something. I'm not going to repeatedly explain it because that doesn't get us anywhere. So we are here. We call the authenticate. We call the authenticate function. It's just an ordinary function call. There's no component mounting or unmounting going on, and the function, as we'll see, well, we will go back. It does trigger a state change as a result of this. So there's a kind of remounting of or re-rendering of this component and all its children. But the important part is this bit here, really, because we programmatically navigate now to the location that is generated by this expression here, which for the example that we're looking at would be the /inbox location. And now we navigate. So if we come back to here, now we've changed the browser's URL address again to /inbox. That means that matches up with this. Protected root will execute again, but on this occasion, this expression here is going to be skipped over because token has a value and nothing it makes it false. And so it's just going to render whatever children is, and children will be inbox. So the inbox page will display. It's by no means straightforward. As I said, the use case is very simple when you think about it, without knowing how it's done. But when you see the implementation, I would argue anyway that it is quite complex because it involves design patterns and all of these various hooks and programmatic navigation, et cetera, et cetera. So if you're struggling a little bit with it, then that's understandable. I always like diagrams to try and explain things to me. I don't know if it works for you or not. I couldn't find anything online that kind of explained it, and I couldn't think of a diagram type that would do it for me. So I just had to come up with something myself. So it's a kind of makey-uppy thing. It may not work for you, but so the flow of control is, so the user, clicks the hyperlink, the inbox. I'm sticking with the inbox one, but it could be any one of them. It could be the profile hyperlink. So any box in my diagram represents a change in the browser's URL address, okay? So the browser's URL address, when the user clicks on the inbox link, it will change to that initially. Whenever the browser's URL address changes, React always creates this location object. And so the location object has a number of properties, but the only one we're interested in is path name. So that's going to be the location object at this stage. According to my routing configuration, the component that is going to be mounted, though, as a result of that is the protected root component. It makes a decision. It checks to see whether there's somebody logged in or not. Let's assume there isn't. So it goes down this route. It changes the browser's URL address again, which means that React creates another location object. And in this location object, it adds some state. And the state is this intent property that we saw a few slides back. Okay, so this, and it grabs the value for, intent from the location object that existed just before the new one was created. So I've got this is my active location object now. By the way, once a location object is created, you cannot get access to the ones that preceded it. Okay. So this is my location object. The URL changes to /login. The routing configuration kicks in. There's an ordinary root entry for that. So my login page mounts. and it calls the authenticate method of the context provider. And the context provider, assuming everything is okay, will reset the browser's URL address to /inbox, because it can grab it, it can find out what it was from here. This location object is available to this component. How does it get access to it? This component here, this component uses the use location hook to get access to this. So it changes the browser's URL address again, assuming the username and password are okay. URL address changes, new location object changes, our new location object is created. According to my routing configuration, the protected root component is going to be mounted, but this time it's going to come down this path here rather than this one. As I said, it makes perfect sense to me, but I don't know if it works for you or not. Study it as you study the code. Now, the code for this is available as a downloadable archive, and this is it here, right? And when you explore it, you see I have a version 1 and a version 2. The version 1 is what I've been talking about, and they are the code excerpts that are in the slides. The version 2 is using a technique called promises. It's a JavaScript programming technique for making asynchronous calls, because in the real world, the authentication, the validation of the username and password would be carried out at the back end. So we'd have to make a HTTP request across the network. And version 2 shows you how to implement that, but it involves using a programming technique called promises, which we have not covered. It's a JavaScript thing, but Frank Walsh will cover that programming idea in his part of the module, and then version 2 will make more sense to you, hopefully. So don't go near version 2 where you can look at it, but may not make a whole lot of sense. So if you want to play with this, the usual thing is go into the index.js, and well, I've set it to version 1, or if it's not at version 1, make sure you set it to version 1, and away you go. Run npm start and then play around with it as much as you wish. Now, there was one slide that I forgot to cover in the lecture, and it's this one here. So there was this new operator added to the JavaScript language more recently called the optional chaining operator, and we use it in the code, but I didn't explain it at the time. So if we look at the code excerpts here, essentially the purpose of this operator is to avoid that common occurring exception that JavaScript throws, which is this trying to access property of undefined. So if we just follow this little code excerpt here, so I'm declaring a variable called var1, and I'm assigning it an empty object. And on the next line, I'm trying to access a property called foo of that object. Now, that expression is going to return undefined. And JavaScript won't throw any exception on this line. But if we look at the next line, then I'm actually interpreting foo as if it's a valid property of var1, and I'm trying to access a property within foo called bar. Now, this line will cause JavaScript to throw a runtime exception, and the exception will essentially say, you're trying to access a property called bar on the undefined type, because we know this expression here, var1.foo, that evaluates to undefined, which is not a valid object. And so trying to index into that will cause an exception, as I said. Now, where this new operator, this optional chaining operator comes in is on the next line. So I've got the exact same expression. I've got var1.foo, but here I'm using the optional chaining before I reference bar. And the way the optional chaining operator works is if the thing to the left of the operator evaluates to undefined, then it doesn't bother trying to evaluate what's to the right of the operator. It will essentially stop evaluating this entire expression once it realizes, I suppose, that there's the possibility of the exception being thrown. And so this entire expression now is just going to evaluate to undefined, and therefore we won't get an exception thrown. Down here, and you can chain on these optional chaining operators as much as you want to. Now, when we need to use that operator, well, it's in the case where sometimes what's to the right of the operator is a valid expression, and sometimes it's not, and that's just part of the logic of your code. Now, where it arises in our authentication code is let's see, where did I use it? Here we go. Let me explain first the kind of user experience where this can arise. So if we go back, I suppose, to our screens. So there are two ways that a user might trigger the display of the login page. One is when they try to access a protected route, and I've explained all of that. The other case is if the user actually clicks this login button, that will take them directly to the login page. Now, in that scenario, the application has no way of knowing where should they redirect the user to, where were they intending to go, because they didn't intend to go anywhere. They just went directly to the login page. And so what I've decided arbitrarily is that if the user does click the login button and take themselves directly to the login page, then by default, we'll send them to the home page. Now, when they do click the login button, that means that this expression here, location.state, that is going to be undefined. And you can go back yourselves and look at when does location.state actually have a valid value? Well, I can tell you, it's going to have a valid value if the user tried to access one of the protected routes and thus was sent to the login page. However, if the user clicked the login button themselves and went straight to the login page, then this expression is going to be undefined. And so we can't try and access a property called intent of undefined. So I'm using the operator chaining expression there to stop essentially this expression here throwing an exception when the user went directly to the login page themselves. Now, there's a second piece of JavaScript code used in this line as well that I should explain, which is over here. This is the logic OR operator in JavaScript. And the way this assignment statement, this is an overall assignment statement here. The way this assignment statement works is if what's to the left of the OR operator is a valid value, as in it's not the undefined or it's not null. If what's to the left is something other than undefined or null, then whatever this evaluates to is assigned to origin. On the other hand, if this expression here does evaluate to undefined or null, then it's what's to the right of the OR operator is assigned to origin. And if you think about it, based on what I said there a while ago, is if the user goes to the login page directly themselves by clicking the login button on the site header, then I said we will redirect them back to the login, to the home page once they have authenticated or logged in properly. And so the home page, its URL is /. So 2 bits of JavaScript magic going on there. I guess the operator chaining operator and this logic or in the middle of an assignment statement. Okay, that's that. Right, it's heavy going for an afternoon, I admit, but see how you get on with it. Now, where are we time-wise? There, yeah. Now, this card here, I just published there about a half an hour ago, and it contains a pre-recorded lecture that I need you to look at in your own time. And what it deals with is explaining the methodology that you can use when you're designing a React app and when you're trying to decide which components should be stateful within your component hierarchy. It's something that I've mentioned way back to you, and I said back then, I gave you component hierarchies and I told you which one I decided was stateful and which one would be stateless, but I didn't explain, well, how did I come up with that decision? This video and the accompanying set of slides explains the methodology or process that you can use to come up with that kind of decision. It's about 40 minutes long, so it's not a full hour lecture. So you need to look at that yourselves and work through the slides as well. The slides are just all text, really. There's no kind of code example, but hopefully it will help you to understand how I might have come up with the designs of the various little demo apps that we've looked at in the other weeks, and as well for the movies app. Right, now, unusually, I'm going to finish there for today. Unless there are any questions from you. So next week, I have really only got one topic to cover, and I won't even need a full lecture. It'll probably be about half a lecture. And I also need to give you the specification for the first assignment for this module, and I'll need to talk through that a little bit with you as well. And then once that's done, then I'm done, and Frank will take the show on from there. So that's it, folks. Unless there's anything you want to ask me before I sign out. No, all right. I'll talk to you in the labs later on in the week. Bye-bye.